Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have fifth lecture and the topic is Rotary Displacement Pumps Part 2. In this tutorial, we will first discuss about general considerations of screw pumps. Then we will discuss about the construction, operation and maintenance of twin screw pumps. Next we will discuss about the construction and operation of triple screw pump. Then we will discuss about the construction and operation of single screw pump. Lastly, we will discuss about the performance of displacement pumps. Let's discuss these through the following slides. Screw pump. Category of the pump. Screw pumps fall under the category of rotary positive displacement pumps which have their unique axial flow pattern with low internal velocity. These are medium capacity pumps with sufficient discharge head. Suitability for liquids. These pumps are particularly suitable for pumping oils of different viscosity. Screw pumps are used on the ships for handling heavy fuel oil. Types of screw pumps. Screw pumps usually have two screws, although some pumps also have three screws. In addition, there is also a single screw pump which is usually employed for handling sludge or bilge water on the ships. These pump types are discussed through the following slides. Screw pump construction. The sketch shows a vertical pump with two screws which are mounted on the base plate. Pump consists of cast iron housing which is suitable for the general range of liquids handled and encloses the pumping elements inside. Pump housing carries two screws rotating in a casing with fine clearance. Unlike the gear pumps, the screws do not mesh together. The screw shafts are normally of high grade carbon steel or stainless steel to resist corrosion. Screw shafts are supported in upper and lower steel ball bearings. In small screw pumps, bushings made from bronze are used instead of ball bearings. Screws are driven by timing gears to prevent their contact, which can cause scuffing. Timing gears are attached to the screw shafts with keys and locked with nut. Timing gears are made from forged steel and rims are case hardened with 0.15 to 0.4% carbon, 0.2 to 0.3% silicon, 0.6 to 1.5% manganese and 0.15 to 0.3% molybdenum. Timing gears run in lubricating oil bath to prevent their wear. Lip seals provided prevent contamination of lubricating oil with the liquid being entered. Sharp seal prevents leakage of oil from the gland around the drive shaft. Top of the pump forms the motor pedestal to mount the electric motor. This arrangement provides saving in space and simplifies pump and motor shaft alignment. Drive shaft is attached with motor through flexible coupling for its drive. Oil enters the pump through the inlet connection, which is drawn from both ends of the screws and is helpful in balancing the axial thrust. Oil is delivered from the pump from the outlet connection, which is located at the middle of the screw shafts as shown in the sketch. Relief valve equipped on the delivery side relieves excessive pressure by diverting the flow back to the suction side. Screw pump operation. Preparation before starting. Before starting the pump manually, it should be ensured that the pump is free to rotate. Ensure that lubricating oil is visible in the timing gear case. Suction and delivery lines are set properly to ensure that there is no obstruction in the lines. For the viscous liquid, heating may be started to maintain desired viscosity. Pump operation. The starting procedure is similar to that of a reciprocating displacement pump. When the pump is started, it creates suction and draws air if the line is not filled with the liquid. It works by trapping the quantity of liquid or vapor in a volume of space which becomes smaller at the discharge or outlet side. The liquid does not pass between the screws but travels between the casing and the screws. A small clearance is maintained between the screws by the timing gears. Stopping the pump. Pump can be stopped by switching off the electric motor. A non-return valve equipped on the delivery side prevents backflow through the pump. Automatic operation. The pump is usually set for automatic operation with one pump in operation while the other in the standby mode. If the pressure of the running pump drops, standby pump starts automatically and an alarm is initiated to warn the duty engineer. Maintenance of twin screw pumps. Screw pumps generally have trouble-free operation, yet following checks must be carried out. Checking for noise from the coupling. Check for any noise from the coupling and ascertain the condition of rubber bushes every 3 to 6 months. Replace worn out rings, otherwise it results in the damage of bolt or coupling. Check for leakage from gland. Mechanical seal or gland packing should be inspected or changed at any site of leakage. Lubricating oil renewal. Observe the condition of lubricating oil and renew oil every 6 months. Pump inspection or overhaul and survey. Pump internal parts may be checked at 30 months interval and again at the time of survey. Worn bushings and bearings may be replaced. Screw sleeve may be checked for wear and changed if required. Triple screw pump. The picture shows a triple screw pump used for handling high viscosity liquids up to 4000 centistroke. The pump works well at high pressure and can be operated at high speed. Being self-priming, the pump is suitable for handling liquids and vapor without loss of suction. A renewable cast iron sleeve is mounted in the cast iron pump housing. The sleeve houses a male screw driven by the electric motor and two female idler screws driven by the fluid pressure. The male screw is supported by bearing and driven by electric motor through flexible coupling. Oil enters through the inlet connection from the free end and moves axially towards the drive end. Through an internal drill passage, oil is supplied to the other end for balancing the thrust. Oil is delivered from the outlet connection of the pump housing. A relief valve diverts high pressure liquid back to the suction site. In this pump, the axial thrust on the power rotor is balanced hydraulically and that of the idlers by thrust washers. Single screw pump. The sketch shows a single screw pump which is used on the ships to handle bilge or sludge and must never be operated dry. This pump is particularly suitable as a supply pump for the oily water separator as it provides laminar flow which helps in easy separation of oil from water. It consists of a screw-shaped stainless steel rotor which rotates in a rubber stator having double internal screw threads. The pump's base plate consists of a bearing housing and the inlet connection. Bearing housing supports the pump shaft which is driven by the motor through flexible coupling. Oil level is maintained in the bearing housing for the lubrication of bearings. A helical rotor is attached to the pump shaft with a universal coupling. As the center line of the rotor moves slightly radial during rotation, thus it is driven by a universal joint. Cross section of the rotor is circular. A rubber stator is attached between inlet and outlet connections in which the helical rotor reciprocates. During rotation, the rotor tightens against the stator and the enclosed fluid is displaced axially through the pump. Liquid enters from one end and is displaced by the rotor axially, which is delivered from the other end. Leakage of liquid around the pump shaft is controlled by the gland. Performance of displacement pumps. The sketch shows various performance curves for displacement pumps. From head flow curve, it is observed that the discharge pressure is independent of speed. However, flow can be increased by increasing the speed of pump. From flow versus pressure curve, it is observed that flow steadily decreases with increase in pressure due to leakage between pump casing or liner and rotor or bucket ring, which is called slip. From the power versus pressure curve, it is observed that hydraulic power is directly proportional to the pressure developed. Frictional power remains steady over the entire range, and the total power absorbed by the pump is the sum total of frictional and hydraulic power. This completes the study of screw pumps. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concept with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship auxiliary systems and deck machinery safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.